Woohoo! Welcome back. This time we're going to be dealing with the third set of formulas for exponents. And once we finish this last set of formulas, you will know everything there is to know about exponents so far. So let's get on. We've got our sparkly vampire here to help us out, and Godzilla, of course, our support carnivore slash omnivore. And so we're going to talk about powers of products. So what does that mean? That basically means I've got a couple things inside a set of parentheses and an exponent on the outside. So let's talk about what happens here. And what happens here is that we end up with, let me rewrite it, AB cubed, which means we've got AB times AB times AB. Now, if we do this, then we can see that we've got all multiplication, pardon me, Vlad, and so we can drop the parentheses, and then we end up with AB, AB, AB. And then a really cool thing happens, which is that we have something called the commutative property or the commutative property, depending on where you learn to say it. And that says that when we've got a bunch of things that are all multiplied together, we can change the order. So I can put all the A's first and all the B's second. And this rule right here is called the commutative property. And it comes, I believe, from the same word that commute does. I'm not sure, but it seems like a good story. So basically, it's moving things around. And so if I move everything around, I see that I get A cubed, right there. There are 3 A's multiplied together and 3 B's. And then we notice, it looks like, and now I'm about to say the thing that you should never say. It looks like the distributive property, at which point I'm going to say stop. Do not call this the distributive property, because there are certain math teachers and mathematicians whose heads will literally pop off their bodies if you do this. The distributive property, let me remind you, looks like this. If we had, say, a 6 on the outside and A plus B on the inside, right, it would look like this. And you would say 6 times A plus 6 times B. This is the distributive property. Okay? It involves multiplication and addition or subtraction. What is this? Well, this, if you're a human being, looks very similar. It seems like you got something on the outside, which you give to each of the pieces on the inside, which seems like the same thing. And as much as I can recognize that, I will also tell you that this is not called the distributive property. But the problem is it leaves us without language, because this is just the power, the third, raising a product to the third power. And that's awkward. So what we can say, and what a lot of people say, is when you've got two things multiplied inside parentheses and you've got an exponent on the outside, basically you give the exponent to each of the factors on the inside. And in my classes, what we generally call it, and I'm not sure how much longer I can use this because her show's been off the air for quite a while, but we call it Oprah-ing, as in Oprah Winfrey. And this is because back when she had a television show, she used to have a talk show. She would invite people over, and then she would say, everybody in the audience gets a new car. Everyone in the audience gets a horse, or whatever she was giving out. And so this feels very much like it. Everybody in the parentheses gets a cubed. Look under your desk. You've got a cubed. You get a cubed. And you get a cubed. So I refer to it as Oprah-ing. You don't have to say that. You could just say we're going to give this exponent out. And if you do call it the distributive property, I will just say, the distributive property is this other thing. But I totally get that they seem very related. So when can we use this? Well, we can use it whenever we're multiplying. So if the two things inside the parentheses are multiplied, we can give out that exponent to both the A and the B, or if they're divided. the A and the B both get that exponent. What's important? Well, you always got to remember we just are not prepared to deal with dividing by a 0, so you can't get a 0 in the denominator. Other than that, the sky's the limit, literally. So, having said that, we now know all the rules. Now, I have written them down on a little card. I don't know that this card is helpful for everyone. Everyone has different ways of writing out the rules, but I just thought I would, before we go any further, before we go into this exciting problem that's down here, let's go through it. What are our rules? Raising a base to the power 0 is 1, unless the base is 0, in which case, game over. If you've got a negative exponent, or the opposite of an exponent, that means you want to put it in the denominator. If it's already in the denominator and it's negative, or you've got the opposite of something, you can move it up into the numerator. Moving it from the top to the bottom or the bottom to the top changes the sign of the exponent. We've got this one that we just learned, x times y raised to the 8th power, x to the 8th, y to the 8th. So the a gets given out to both of them. If I have x to the a times x to the b, so same base with two exponents, I add them. If I have one base with two exponents, I multiply them. That was what we did at the very end of part 2. If I have two bases with exponents and they're divided like this in a fraction, I subtract. And when I subtract, I start with whoever was there first. So x to the a, x to the a minus b. If I'm going to put it up on top where the a was, I start with a and I subtract the b. If I put it in the denominator, b was there first. So I start with b and I subtract the one I'm moving, the a. And then down here at the bottom, I've got just a handy reminder, x to the 2nd power is also called x squared. I should put that in quotation marks. X raised to the 3rd power is also called x cubed. And x raised to the 4th power really is just x to the 4th power, although you don't have to use the word power. You can just say x to the 4th if you want to be really cool. And those are all the exponent rules right there. So that may not be the way you want to write it, but definitely make sure you've got a list of all those different properties. And let's go ahead and do a couple final problems. So one of the hardest things, I think, as a student is being asked to simplify. If you're asked to simplify and you're working with just, any sort of math problem, any sort of algebra problem, it's hard to know what's more simple. And so I'm going to try to go through an explanation of when something is simpler, or when something is, maybe a better form to answer. But sometimes there's going to have to be some judgment calls. So if you're ever working with a problem where it says simplify and you're like, you know what, this is what I got, but I don't know if this is the simplest form, this is what you'd like, you can always ask. Definitely ask lots of questions. Okay, so I've got a very, very complicated problem. You can see I've got a lot of stuff going on. So as is my wont, I'm going to write the whole thing out. Now, I noticed that there are some things that are matchy-matchy, but right now I'm not sure how they interact. So I'm just aware of that, and I'm just thinking, oh, that's interesting. So I'm going to go ahead and I'm going to work on each part separately and just see what I can do with it. So generally with simplifying, you're going to be looking for things that can cancel. You're going to be looking for things that, things that you can combine. For this problem, I see I have exponents on the outside and parentheses, and this is exactly what we were just studying. So I'm probably going to give out these exponents. So this will be 2 to the negative 2. Give out the negative 2. A to the negative 1st to the negative 2. Right, that comes out. And then b cubed to the negative 2. These are the first 3. Then in the second 3, I've got 2, give out the 2. A to the negative 1, give out the 2. B cubed, give out the 2. So I am giving the 2, in this case, to each of these 3. And in the first case, I was giving out the -2 to each of the 3. Okay, so that was my first step. Now my next step that I'm going to follow is, in case of like this A has 2 exponents, I know that I have a formula that says when I've got an exponent on the inside, exponent on the inside, exponent on the outside, I multiply them. So I'm going to go ahead and do that next. I've got 2 to the -2. A, -1 times -2 is going to be a +2. B, and the exponent will be 3 times -2, which is -6. Here I've got a 2 squared. I've got an A to the -1 squared. So -1 times 2 is -2. And B raised to the 3rd power squared. So 3 times 2 is 6. Now I've got a bunch of things. These are all multiplied together, right? And so now I'm going to go ahead and, there are a couple ways to do this. I'm going to just put everyone who's happy with being on top, leave them on top. Anyone who's a vampire, let's get them down in the basement so that they're not miserable, right? So let's go ahead and do that. I'm going to go ahead and say, okay, great big apartment building. 2 to the -2, not happy. So it's going down in the denominator. Once I move it into the denominator, it's happy. So every time you move something, the exponent will change. There's that one. Okay, A squared, happy. B to the -6, not happy. Let's put him down in the denominator. And again, once I move him, I change the sign. So this is right there. The 2 squared stays up here. I'm realizing I need a lot more colors here. Here's the A squared, stayed up on top. I'm going to run out of distinct colors. Here's yellow, is right there. Sorry, I went to Smeary Town, didn't mean to do that. Let's see, I might be able to get away with the red. A to the -2. A to the -2, not a happy guy, so let's move it down the denominator. Happy little vampire. That's one thing Bob Ross never did. He never drew any happy little vampires. That seems like a missed opportunity, you know? Okay, and then here's a purple. The B to the 6, not a vampire. Happy little regular human person. And so that stays up there. And then let me combine. Let me see what's going on. I've got A squared times 2 squared, which is 4, times B to the 6th, all over 2 squared, which is 4, B to the 6th, times A squared. And then I realize something. I look at this and I go, wait a minute. The 4's cancel. The A squareds cancel. The B to the 6th cancel. Everything just canceled. This is like the perfect, the ultimate goal for fractions. Everything canceled. We end up with 1. What the heck happened? How did everything cancel? How did we not notice it? Let's go back to the beginning. Notice that in the beginning, 2a to the -1st b cubed, 2a to the -1st b cubed, they're the same. This one is raised to the -2. This is raised to the 2. So if we've got the same base, one is raised to -2, one is raised to 2, you add them, -2 plus 2 is 0. So this was ultimately, it canceled itself out. It equaled 1. So kind of cool. Shall we do another one? Woohoo. Let's do another one. Yay! Okay, so this one, dun dun dun! We can do it though, slow and steady. So this particular problem can be done in many ways. The 2 big ways to do this problem are to either cancel inside the parentheses and then deal with the 4, or if you prefer, to give out the 4 to everybody and then cancel. And as much as it surprises me, students often say that they would rather I give out the 4 first. So I'll go ahead and do it that way. So I've got -4 x to the fourth y squared all over 6x to the negative first y to the fourth all raised to the fourth power. Now, if you're curious, I would absolutely simplify inside first. So, and if you ever want to see me do something different than the way I do it in a video or in class, definitely ask during office hours, talk to tutors, we'll hook you up. I'm going to give everybody one of those fourths. So it goes to everybody. Remember, it's not the distributive property. It just kind of looks like it. So I've got negative 4 to the fourth power. Why can I include the negative with the 4? It's a good question. And the answer is because it doesn't matter if you don't include it. If there's just a minus, that would be negative 1. So it would be negative 1 to the fourth power and then a 4 to the fourth power. And you get the same answer. Okay, x to the fourth and y squared to the fourth all over 6 to the fourth, x to the negative 1 to the fourth, and y to the fourth to the fourth. And so now you have to remember, what do you do when you've got an base and then an exponent with another exponent outside? You multiply. Okay, so I've got, let's see, this one, negative 4 to the fourth. I'm just going to have to calculate that, and I'm going to put it off for right now. The second term, x to the fourth, I'm going to multiply. I get x to the 16th. And then y squared to the fourth, I multiply. I get 8. Down here, this will be 6 to the fourth. Again, I'll calculate that later. X to the negative 1 to the fourth will be x to the negative 4. And y to the fourth. Remember, I multiply, don't add, multiply, and that's y to the 16th. So far, so good. It's getting better. Okay, now it's going to be time for me to calculate these. And I'm just going to say, you know what? I could do this in my head, but I feel more comfortable doing it on a calculator. Problem like this, you are absolutely welcome to use a calculator for. Now, here's what's important. Negative 4 to the fourth power, you need to include the parentheses if you're going to use your calculator. So I use parenthesis, and then remember that a negative is not a minus. So I've got this, the line that's right next to the plus in the multiplication, that's a subtraction. That's not that. Unfortunately, calculators are not as good as humans are. They're not as flexible. We have to tell it whether it's a subtraction or an opposite sign. This guy is a negative 4, which means we have to use this one. Sometimes there's a key here that has a plus and a minus on it. Take a look at your calculator. If you have trouble finding your negative sign, let me know. We can help you find it. So I've got negative 4, and that's going to be, on this calculator, I'm going to use this, the exponent key, raised to the fourth power. And that's 256. X to the 16th, y to the 8th, all over, and then this one's much easier, 6 raised to the fourth power is 1296. Ugh, this is going to be a lot to deal with. Y to the 16th. Okay, so far so good. We're getting in there. Now I can tell that I'm going to have to reduce things a little bit. Now, could I have simplified this more easily if I had worked in the original problem, like canceled the 4 with the 6? Absolutely, that would have been easier. But that's okay. You don't have to worry about that. I think about, okay, so 256. I'm going to guess 4 goes into 256. I'm going to guess that 4 goes into 1296. So if I take 1296 divided by 4, that's going to be 324. So 324. And then 256 divided by 4 is going to be 64. Okay, so that's, I can cancel that. Then I realize, okay, I've got 64 on top. I've got x to the 16th. I've got y to the 8th. Down in the denominator, I've got 324. So I've still got some stuff I can reduce here. This x to the negative 4, not happy. I'm going to move it up here, x to the 4th. Right? It's happy. It's a human. And this is y to the 16th. Okay, so let's see. 64 and 324. I bet 64 is divisible by 4. So I get 16. And 324 divided by 4 is 81. Okay. Then I look at these and I go, okay, 16 is 4 times 4. 81 is 9 times 9. They don't have anything in common, so that is reduced fully. The 16 over 81 does not reduce further. The x to the 16th times x to the 4th is x to the 16 plus 4, right? Because they're multiplied, they're at the same level together, so I add them. Now, what do I do with the y? If I've got a y to the 16th on the bottom and a y to the 8th on top, I've got more y's. There's 16 y's. Y. Up here, y, but fewer. So I want to bring them all into the denominator. So I start with the 16, but when they're in different spots, I'm going to subtract. Right? Because this is division. This is multiplication, so we add. This is division, so we subtract. Okay, so I get 16x to the 20th all over 8y to the 8th. Now, are there other ways to do this? Absolutely. But this is the way that a lot of students prefer. And again, always ask if you'd like to see a problem a different way, if you don't quite understand what's happening, if you're curious, if you've got an alternate solution and you want to see, like, is this going to work all the time or did I just find a special case? Ask. I'm perfectly happy. This is literally what I want to do with my life. I want to help people understand math because I think that when the world is happy and doing what they want to do, the world is better for everybody, including me. So it's totally selfish. I just want to have a great life. Okay, so number 3. Wow, that escalated quickly. So for this one, I'm going to follow a different approach. So for the previous problem, what did I do? I went ahead and I just gave everyone the 4. For this one, I want to try simplify inside first. Now, if you're taking notes, you might want to make a note that I'm saying, you know what? You could just give everybody the -2. That would be fine. But I want to go ahead and simplify inside first for myself, just to see how it goes. So I'm going to look at 8x y squared c to the -2 all over 4x y to the -1 c to the -4. And I know there's a -2 outside. I'm just going to leave it there. It'll be fine. It'll be fine. Okay, so first things first. This 8 and this 4 I can cancel. That's going to make a lot of things easier for me. So instead of dealing with 8 and 4, I'm just dealing with 2. Next up, the x's. If whatever's on top and whatever on the bottom, if they match, they cancel. So the x's cancel. So they're not in there anymore at all. Okay. Y squared, y to the -1. There are a lot of ways to deal with this. It's already complicated. So what I'm going to do is I'm just going to go ahead and say y squared is happy. Y to the -1st, not happy. So I'm going to move it up top and make it y to the 1st. So this was not a vampire, right? This was a human. Wanted to come up on top. Next up, z to the -2. Is the z to the -2 happy? No. That is a vampire. So I'm going to move that z squared down in the denominator. But then the z to the -4, also not happy. Everyone's miserable. This is just this. We started out with a really difficult situation. Everyone was cranky. So z to the -4, I move it on top, and then I make it happy. Now, this is where it becomes clear that you really need to make sure you can differentiate your 2's from your z's, because we're going to use a lot of problems where we'll use both. Okay, so let's come over here. I've got 2 y squared, y to the 1st all together right here. I've got 3y's. Y to the 2 plus 1, since we're multiplying. And then here I've got z to the 4th on top, z squared on the bottom. Let me simplify things by saying I'm going to take the z to the 4, because there are more of them up top, and I'm going to subtract the 2 on the bottom. Does that make sense? Because they're in different spots, so I'm going to subtract because I'm dividing. This is all raised to the negative 2 power. Okay, so I've got, where'd the denominator go? And the answer is, oh, if there's nothing more in the denominator, I put a 1 there. Okay, so I've got a 2y cubed z squared all over 1 to the negative 2, which is just 2y cubed z squared to the negative 2. Okay, so is this simplified? And the answer is no. If I've got exponents on the inside and exponents on the outside, and there's no addition anywhere, I need to keep going. Okay, so for my next step, I'm going to go ahead and give everyone the negative 2, which makes Vlad here very excited because you can see what's happening. Everyone gets turned into a vampire. Blah, ha, ha, ha. So this is 2 to the negative 2. Y cubed to the negative 2, that's y to the negative 6. And z squared to the negative 2, what is that? That's z to the negative 4th. Everybody wants to be a vampire now. So I move the y to the negative 6 down into the denominator, it becomes y to the 6th. I move the z to the negative 4 down into the denominator, z to the 4th, and the 2 to the negative 2 becomes 2 squared. So the whole thing is 1 over 4, y to the 6th, z to the 4th, and you guys are amazing and awesome, and we are done. Bam! So for Godzilla and for the Sparkly Vampire, I want to congratulate you. You're awesome. This was a really hard series of videos. There's a lot going on, a lot of details. So make sure you take the time, practice. And if anything is bugging you, if you can't get an answer, you're just frustrated, you're feeling confused, ask, please ask. There's no reason for you to go through life feeling frustrated and confused by math. I definitely want to give you the opportunity to learn it and to feel like, okay, I got it, and then to feel comfortable with the material. Woohoo! So go out, take a break, get some snacks, get some hydration. Know you're awesome and amazing. Know that I want you to succeed, and I think you're incredible. And math on.